Now we are going to talk about balancing of a redox reaction. So what do you think? Is it very complicated, right? You must be thinking that way. Let me tell you, if you understand the steps, it is not that difficult. So I'll break it down step by step so that you can easily understand the overall process. Alright. So I'll explain it through an example. So I take an example of a reaction where dichromate ion is oxidizing Fe2 plus into Fe3 plus, and dichromate ion is getting reduced to Cr3 plus. I have taken this example to make you understand what are the steps in balancing a redox reaction. So check out. So firstly what we will do is we will figure out which species is getting oxidized and which is undergoing reduction. Let's see. So iron is in +2, it is going to +3. So this is oxidation. I think you are very much sure. Increase in oxidation number, +2 to +3, increase in oxidation number, and increase in oxidation number means it is undergoing oxidation. So Fe+2, Fe+3 is oxidation, and dichromate +6 is the oxidation state of chromium out here, and it is going to chromium +3. So this is basically reduction. So what will be the first step? The first step will be to separate oxidation reaction and reduction half reaction. Overall reaction is redox. So there are two parts, oxidation part and reduction part. Separate each of them. So I will separate each of them. So firstly I have taken dichromate, which is going into chromium 3 plus. What is happening? There is a reduction half cell. Reduction halves. Reduction half, and oxidation is happening out here. Oxidation half reaction. Here Fe+2 is going to Fe+3. Alright. Oxidation half reaction and reduction half reaction. Now we are going to balance each of them separately, and at the end we will add them up. That's it. So what will be the first step to balance? First step is to balance the atoms of elements other than oxygen, hydrogen. Balance atoms of elements other than oxygen, hydrogen. So I will see there are two atoms of chromium this side and there is one atom of chromium that side. So I will put 2 out here. Now chromium, 2 atoms are here and 2 atoms here. Oxygen, I told you we will be balancing later. So I have balanced atoms other than oxygen, hydrogen. Here you have one atom of iron this side, one atom of iron that side. So we do not need to balance any atom because it is already balanced. Now next step is balance oxygen by adding water. Balance oxygen by adding water. So we have 7 oxygen atoms out here. So as each water molecule has one oxygen, so we will add 7 water molecules out here. We will add 7 water molecules out here. Alright. So this is it. We have added 7 water molecules that side because 7 oxygen were this side. Now next step is balance hydrogen atoms by adding H plus. So we can observe we have 14 hydrogen atoms this side and no hydrogen atom that side. So we will add 14 H plus on the side which has less number of hydrogen atoms. So we have added 14 H plus out here. Alright. Now next is what? Next is balancing. Here also you can check out we do not have any other atom, so there is no balancing of atom required. Now we have balanced chromium atoms, oxygen atoms, hydrogen atoms. Chromium 2 atoms, 2 atoms, oxygen 7, 7 atoms, and hydrogen 14 and 14. So all atoms are balanced in both the half reactions. Next point is firstly balance the atoms, next balance the charges. So what was the first step? Balance, separate the oxidation half reaction and reduction. Next balance atoms other than oxygen, hydrogen. Next balance oxygen by adding water. balance hydrogen by adding H plus. Now we have balanced atoms of all elements, and the next step is to balance the charge. Let's see. So what is the charge out here? -2 is this, and 14 plus. So 14 plus -2, what will be total positive? 12 plus this side, and we have 6 plus on this side. 6 plus this side and 12 plus this side. Now we will be balancing charge by adding electrons. 12 plus 6 plus. So we need to add electrons. So each electron is -1. Each electron has a charge of -1. 12 plus is this side, 6 plus this side. So I think you will agree with me that we should add 6 electrons on this side. Now total charge -2 plus 6, 8 negative and 14 positive. 8 negative and 14 positive. So total is 6 positive. 6 positive this side. Now let's see. This is balanced on the basis of charge. Come this side. 2 plus and 3 plus. I think you will agree that we should add 1 electron this side. So net charge +3 -1, that will be +2 this side and +2 this side. So charges are balanced in both the reactions. Final step is to see how many electrons are getting added in this. Reduction is happening, 6 electrons are being added. So there should be loss of 6 electrons that side. So we will multiply this reaction by 6. So we will multiply this reaction by 6. So you get this. So there is loss of 6 electrons that side. We have gain of 6 electrons this side. Now I think we have come to the end of our balancing process. Just add these two reactions to get a balanced reaction. So we will add these two reactions to get the balanced reaction. So how it will look like? It will look like this. See, dichromate Cr2O7 -2 plus 14H plus. We will bring this 6Fe2 plus. Now we will go to the right hand side, 2 chromium 3 plus. Then we have 6Fe2 plus 3 plus. Then 7 water molecules. And we will be cancelling out these 6 electrons, because this is on LHS and that is on RHS, and we will cancel them out. Now we get this balanced reaction. What will be the last step? Check whether all atoms in LHS equals to all atoms in RHS. Next point, check the charges. So let's see. Chromium 2 atoms, 2 atoms, oxygen 7, 7, hydrogen 14, 14, iron 6, 6. So atoms are balanced. Now check the charges. -2, and this is 6 to the 12, 12 plus 14, that is 26 positive and 2 negative. That means 24 positive. Let's see. 2 3s are 6, 6 3s are 18, 18 plus 6, that is 24 positive. That means charges are balanced on both the sides and atoms are balanced on both the sides. So we get a balanced redox reaction. So just remember these points and you will always be able to get a balanced reaction from an unbalanced reaction. Just remember the last point, that gain of electron should be equal to loss of electron. If required, just multiply a given equation by the required number or the desired number. So I hope you must be able to understand successfully what the balancing process is. So this is one of the important topics of the redox reaction where questions are usually asked. Balancing of a redox reaction, you must practice more so that you are very confident about it. Thank you.